Imagine waking up one morning to a scientific announcement that sounds impossible. Every grain of salt in Earth's oceans has vanished overnight. The water is still there. The waves still crash against the shore, and the oceans still cover more than 70% of the planet, but something fundamental is gone. At first, many people might celebrate. After all, salt water has become freshwater. Desalination plants would no longer be necessary, and some might think humanity has suddenly gained an endless supply of drinking water. But beneath the surface, a global disaster would already be unfolding. The disappearance of ocean salt would trigger one of the most catastrophic chain reactions in Earth's history, affecting everything from microscopic organisms to global weather systems, and even the survival of human civilization. To understand why, we first need to understand what salt actually does in the ocean. Ocean water contains dissolved minerals, primarily sodium and chloride ions. These salts are not just impurities floating around in the water. They are a critical part of the ocean's chemistry and physical behavior. Salt affects water density, freezing temperatures, circulation patterns, and the biological processes that support marine life. In many ways, salt is one of the invisible foundations of Earth's environmental stability. The first major consequence would occur among marine organisms. Nearly every creature in the ocean has evolved over millions of years to live in saltwater. Fish, plankton, corals, shellfish, and countless microorganisms depend on a specific balance of salt inside and outside their cells. If ocean salinity suddenly dropped to zero, most marine species would experience severe osmotic shock. Water would rush into their cells, disrupting vital biological functions. Many organisms would swell, become damaged, and die within hours or days. Entire ecosystems that took millions of years to develop could collapse almost instantly. The devastation would begin at the bottom of the food chain. Tiny organisms known as phytoplankton are responsible for producing a significant portion of the oxygen humans breathe. These microscopic life forms thrive in salty ocean environments. Without salt, massive populations of phytoplankton would perish. As they disappeared, countless other species that depend on them for food would also suffer. Small fish would lose their primary food source. Larger fish would lose prey, and predators such as sharks, dolphins, seals, and whales would struggle to survive. What begins as a chemical change in the water would rapidly become a biological extinction event. Coral reefs would face an especially grim fate. Often called the rainforests of the sea, coral reefs support an extraordinary diversity of life. Corals are extremely sensitive to changes in their environment, and a sudden loss of salinity would likely kill most reef systems around the world. As reefs died, thousands of species that rely on them for shelter and food would disappear as well. Entire marine communities would vanish, leaving vast underwater deserts where vibrant ecosystems once flourished. The effects would not stop with marine life. Salt plays a crucial role in regulating ocean circulation. One of the most important systems on Earth is the global thermaline circulation, often called the ocean conveyor belt. This massive network of currents moves heat around the planet by transporting warm and cold water between different regions. Salinity helps determine the density of seawater, which drives these currents. Without salt, the density differences that power this system would largely disappear. Ocean circulation could slow dramatically, or even stop altogether. The collapse of major ocean currents would have enormous consequences for global climate. Regions that currently enjoy relatively mild temperatures due to warm ocean currents could experience dramatic cooling. Parts of Europe, for example, benefit from heat transported by the Atlantic Ocean. Without this heat transfer, winters could become far colder. At the same time, tropical regions might become even hotter because excess heat would no longer be distributed effectively around the globe. Weather patterns that humans have relied upon for thousands of years would begin to shift unpredictably. Rainfall patterns would also change. Oceans supply the moisture that drives much of Earth's precipitation. Altered temperatures and circulation patterns could disrupt monsoons, storm systems, and seasonal rainfall. Some areas might experience severe droughts, while others could face increased flooding. Agricultural systems around the world would struggle to adapt. Crops that depend on predictable weather conditions could fail, threatening food security for billions of people. Another surprising consequence involves the freezing point of water. Salt lowers the temperature at which seawater freezes. Ordinary seawater freezes at around -2 degrees Celsius, while pure freshwater freezes at 0 degrees Celsius. If the oceans suddenly became fresh water, polar regions would begin forming sea ice more easily. Vast areas of the Arctic and Antarctic oceans could freeze more rapidly and extensively. Increased ice coverage would reflect more sunlight back into space, potentially cooling parts of the planet. However, this cooling effect would interact with other climate disruptions in complex ways, creating conditions scientists would struggle to predict accurately. Marine chemistry would undergo dramatic changes as well. Salt helps maintain the stability of numerous chemical reactions in ocean water. The sudden removal of dissolved minerals would alter nutrient availability and disrupt biological cycles involving carbon, nitrogen, and phosphorus. These cycles are essential for supporting life and regulating Earth's atmosphere. As marine ecosystems collapsed, the ocean's ability to absorb carbon dioxide from the atmosphere could decline significantly. This could contribute to additional climate instability and further environmental stress. Human economies would feel the impact almost immediately. Fisheries support millions of jobs and provide food for billions of people worldwide. With marine ecosystems collapsing, fish populations would crash. Entire fishing industries could disappear within a relatively short period. Coastal communities that depend on seafood production would face economic devastation. Nations heavily reliant on fishing exports could experience severe financial crises. Shipping and transportation might also be affected. Saltwater is denser than freshwater, which means ships float slightly higher in the ocean than they would in freshwater. While vessels would not suddenly sink, changes in buoyancy would require adjustments in ship design, loading practices, and navigation. Ports, harbors, and maritime industries would need to adapt to entirely new conditions. Combined with worsening weather and changing ocean currents, global trade could become more difficult and expensive. Human health would face unexpected challenges as well. Although the oceans would technically become fresh water, that does not mean people could simply drink from them. Ocean water would still contain pollutants, microorganisms, and other contaminants. Moreover, the environmental collapse triggered by the disappearance of salt would likely create widespread shortages of food and resources. The loss of seafood, disruptions in agriculture, and extreme weather events could increase the risk of famine and humanitarian crises across many regions. Over longer timescales, geological processes would begin attempting to restore balance. Rivers constantly carry dissolved minerals from rocks into the oceans. Volcanic activity and hydrothermal vents also contribute salts and minerals to seawater. Gradually, over thousands or even millions of years, salinity would begin to increase again. However, by the time natural processes restored significant amounts of salt, much of Earth's existing marine biodiversity could already be gone. Entire evolutionary lineages might vanish forever. The disappearance of ocean salt would also serve as a powerful reminder of how interconnected Earth systems truly are. Something as ordinary and overlooked as salt influences climate, biology, chemistry, and weather on a planetary scale. Most people think of salt as a seasoning on a dinner table, but in the oceans it functions as one of the essential ingredients that make our world habitable. Remove it, and the consequences spread through nearly every aspect of life on Earth. What makes this scenario so fascinating is that it highlights how delicate the balance of our planet really is. The oceans are not simply giant containers of water. They are complex systems shaped by countless interactions between chemistry, physics, geology, and biology. Every wave, current, and ecosystem depends on conditions that have remained relatively stable for millions of years. Even a single dramatic change can trigger consequences far beyond what anyone might initially expect. So if all the ocean's salt suddenly disappeared, the result would not be an endless supply of freshwater or a more comfortable world. Instead, it would unleash a cascade of environmental disasters. Marine ecosystems would collapse, global climate patterns would shift, food supplies would be threatened, and human societies would face challenges on a scale rarely imagined. In the end, the disappearance of ocean salt would reveal a simple but profound truth. Some of the most important things on Earth are the ones we barely notice, quietly holding the entire system together while life goes on above the surface.